Let us work on our enemy next. The enemy is going to be a bit similar to the player at its core. So we're going to go to the source folder, actors subfolder, and select player.tscn and right click, duplicate it. We are going to call that enemy.tscn. Voila. Double click on that new scene to open it. Right now our enemy looks just like the player. So we're going to select the first node, call it enemy. Second node, the player sprite, we're going to call it enemy as well. And in the file system, we're going to search for our enemy. You will see in the assets folder an enemy.png file, so you can also expand the assets folder. And with the enemy sprite node selected, you can click and drag enemy.png onto the texture slot, replacing the player with the enemy. We're then going to adjust the collision shape here for the monster, make it maybe a bit smaller, let's say, at the base, maybe a bit larger as well. This is the part of the monster that is going to collide with the walls, that is going to block the player as well, or hit and kill the player. This should do. Now, let's select the base enemy node. Because we duplicated our player scene, the enemy still has the player script attached to it. So we're going to right click on the enemy and we are going to choose extend script. We're going to change in the inherit slot the script that the enemy is going to extend. So click the folder icon and double click actor. The template is going to be empty and the path by default should be enemy.gd in our actors folder. Click create to have your enemy script. Back to the enemy scene, we have to change one last thing. It's for the collisions. Remember these layers and masks? If you select the enemy node, the enemy is still set to be on the player layer. Instead, you want to put it on the enemy layer, and it's going to collide with the world. So the mask property allows us to control that, and with the player. So with that, we can get started coding our enemy. Save the scene, click to open the enemy script. I'll close the kinematic body to the docs. And we're going to make it so the enemy is going to change direction when it touches a wall. So to code the movement, once again, we're going to add that physics process function. For the enemy, we are going to make it move at a constant speed, like the player, and we are going to make it so if it hits a wall, it's going to change direction. So here's how we do it. Remember that we have our velocity property on the enemy just like with the player, because they extend the actor script. We're going to change the x velocity of the enemy when it hits a wall. So in kinematic body 2D, we have, just like the isOnFloor function, an isOnWall function that we can call. And if the enemy is on wall, we're going to multiply the x velocity by -1. You can use this shorthand to say multiply velocity.x by -1 by using the asterisk equal, so that you don't have to repeat, velocity.x equals velocity.x times -1. We are also going to move the enemy on every frame. Now, the tricky part here is to decide if we move it before doing that check or after that. You have to understand that these methods, isOnWall, isOnFloor, they only update after you move the enemy. So we can move it first, and then on the next frame, it will change direction. Well, in this case, whether we move before or after the check is not going to make a lot of difference, but let's put it after for good measure. So we can say velocity is equal to the result of a move and slide call, to which we pass our velocity, how we want the monster to work, and our floor normal, like so. We're going to do one last thing. We're going to ensure that the enemy always moves towards the player at the start of the game. So our game is going to be so that the player is going to move to the right, just like a Mario game, meaning that the enemy always have to move left at the start of the game. That's what we want. So I'll press F3, go back to the script editor, and I'm going to add a new function. It's another function defined on Godot itself. It's called ready. The ready function is called by Godot on every node in the scene in your game, starting from the one deepest in your tree. In the case of our enemy, it would look at the enemy, see that it has children, so it will go to its children, the enemy sprite and collision shape 2D, and call the ready function there. Once these are ready, it will call ready on the parent enemy node. If we take our level template as an example, the Godot engine will see level template has children, the tile map, the player. So it will go down to the tile map, call its ready function, down to the player, call the ready function on the child node of player, then on player, etc. So it goes from top to bottom in the scene tree order, and from the deepest to the highest level node. So this ready function allows us to set up our enemy in this case. So we can say in the ready function, velocity.x is equal to minus speed.x. In other words, it's going to go to the left at the speed defined by the x component of the speed vector. We're going to test our enemy in the level template. So let's go back to the level template scene, look for our enemy.tscn file, and drag and drop it onto the game. Then we can play and see that the enemy moves left. Now, it's not really falling, so we want to add to our enemy script, applying the gravity on every frame. So we're going to do velocity.y, we're going to add gravity times delta. The enemy script being much simpler than that of the player, while not creating a function to calculate the move velocity, because it would only be 2 lines of code. Now with the code that we have, if we place the enemy close to the wall in our level template, you will see that the enemy gets stuck on the wall. The reason for that is this code gets called, but the problem is that when we assign the result of move and slide to the velocity, when the enemy hits the wall, we reset the x velocity back to 0. So we want to make sure that from move and slide, we only use the y velocity here. Velocity.y equals, so we call move and slide, and we take the y component of the resulting vector. And with that, the enemy will now bounce when it hits a wall. You'll see that it also does that when it touches the player, because right now we don't kill the player when the enemy hits it. We don't do it just yet, we're going to do it soon.